The following is a keynote speaker presentation from the ACM 97 conference, The Next 50 Years of Computing. ACM 97 brought together over 2,000 leaders and luminaries from all aspects of the computing world to discuss and predict what the next 50 years of computing has in store. ACM 97 underwriters were Computer World, Hewlett-Packard, Intel, Microsoft, and Sun Microsystems. Sponsors were Cadmus Journal Services, IBM, Netscape, Popular Science, Sheridan Printing Company Incorporated, Silicon Graphics Incorporated, SoftBank, and Unisys. The event also included a major exposition with a paleotechnic look back to the future from the year 2047, and a specially commissioned book, Beyond Calculation, featuring essays on the next 50 years of computing by luminaries and pioneers in the field. The ACM 97 conference was chaired by Robert Metcalf and emceed by James Burke. Details on how to obtain more information on ACM 97 follow this program.
Ladies and gentlemen, James Burke.
I was going to say that our next speaker is going to take another way out look at things, but having heard Bruce, I'd say relatively way out. He started with a doctorate in computer science back in '66 when he came to America from his native India via another degree in Australia. After teaching for a while at Stanford, he moved to Carnegie Mellon, where he was named a professor in '84, and he's now the Herbert A. Simon Professor of Computer Science and Robotics. And he's recognized worldwide for his work on speech recognition and as the founder of the Carnegie Mellon Robotics Institute, which he ran until he took up his present position as Dean of the School of Computer Science there. He's a member of the Computer Science and Telecommunications Board of the National Academy of Sciences, and he was chair of the DoD's ARPA Information Science and Technology Group from '87 to '90. In '84, he was awarded the French Légion d'honneur for his work on bringing advanced technology to developing countries. His ongoing interest is in human-computer interaction. He has projects running at the moment on speech recognition, multimedia technologies, collaboration techniques, just-in-time techniques, and automated machine shop. All the more interesting then, with a background like that he should choose this morning to talk about something like teleportation, time travel, and immortality. I think it promises to tickle the fancy. Ladies and gentlemen, Raj Reddy.
Good morning. When I heard I was supposed to follow Bruce Sterling, I threw caution to wind and decided not to talk about strategic directions in computer science and talk about what else? Teleportation and immortality. 50 years ago, when ACM was just being formed, the sense of excitement was no less palpable than it is today as we look forward to the next 50 years. Vannevar Bush had proposed Memex with hyperlinks between documents. Turing, having successfully broken the German code using a special purpose digital computer, proposed a universal computing engine called ACE. John von Neumann had recently formalized the idea of a stored program computer, and Eckert and Mauchly had created ENIAC, the first electronic digital computer. There is no question that the last 50 years have been exciting, dramatic, and in many ways full of unanticipated events that have changed our lives. What will the next 50 years bring? Given the exponential rate of change, it is reasonable to assume that the next 50 years will be even more dramatic than the last 100 years. When you recall 100 years ago, there were no cars and no highways, no electric utilities, no phone system, no radio or TV, no airplanes. You can well imagine the magnitude of the change that awaits us. In December the December issue of 1966 of the ACM Computing Surveys has 22 working groups who have produced the strategic directions of research in computer science. I refer you to that for if you're more interested in what is going to happen in computer science research. But I'd like to tell you about teleportation, time travel, and immortality. One of our most compelling, enduring fantasies of the future has been the Star Trek, where the themes of teleportation, time travel, and immortality have captured generations of our imagination. What will the technology look like in the next 50 years? We have heard about this several times in the last 2 days. I'd like to give you one other perspective. By year 2000, we can expect to see a giga-PC, a billion operations per second, billion bits of memory, billion-bit network bandwidth, to be available under $2,000. Barring the creation of a cartel or some unforeseen barrier, technological barrier, we should see a tera-PC by year 2015 and a peta-PC by year 2030, well before 2047. The question is, what will we do with all this power? How will it affect the way we live and work? Many things will hardly change. Our social systems, the food we eat, the clothes we wear, and mating rituals will hardly be affected. Others, such as the way we learn, the way we work, the way we interact with each other, and the quality and the delivery of the healthcare, will undergo profound changes. First and foremost, we can hope that Bill Gates will use some of this computing power to create computers that never fail and software that never needs rebooting. And yes, I can do without the leisure that I get at the boot time and at the closing time of the Windows 95. Thank you. The improvement in the secondary memory will be even more dramatic. Many of you know that while the processor and memory technologies have been doubling every 24 hours or less, 24 months or less, disk densities have been doubling every 15 months or so, leading to a 1,000-fold improvement every 12 to 13, 14 years. Today, you can buy a 4 gigabyte disk memory for under $400. 4 gigabytes can be used to store about 10,000 books of 500 pages each, larger than most of our personal libraries in home. By year 2010, we should be able to buy 4 terabytes for about the same price. At that cost, each of us can have a personal library of several million books, a lifetime collection of music, and a lifetime collection of all your favorite movies thrown in on your home PC. What you don't have on your PC will be available at the click of the mouse from the Universal Digital Library containing all the authored works of human race. If you choose to, you will be able to capture everything you ever said from the time you were born, from a baby babble to your last breath, in under a few terabytes if you want it in stereophonic hi-fi. Everything you ever did and experienced can be stored in under a petabyte. All of this storage will only cost you $100 or less by year 2025. So how will this all affect the way we live and work? We have heard a number of dreams for the future in the past few days. I'd like to share with you some of my dreams on how this technology will be used to save lives, provide education and entertainment on a personalized basis, provide universal access to information, and improve the quality of life of the entire human race. The first area that will have a major impact on society will be the invention of an accident-avoiding car. Let us look at the current state of this technology. Can we show the videotape now, please?
The Carnegie Mellon NavLab project brings together computer vision, advanced sensors, high-speed processors, planning, and control to build robot vehicles that drive themselves on roads and cross-country. The project began in 1984 as part of ARPA's Autonomous Land Vehicle program, the ALV. In the early 80s, most robots were small, slow, indoor vehicles tethered to big computers. The Stanford cart took 15 minutes to map obstacles, plan a path, and move each meter. The CMU Imp and Neptune improved on the cart's top speed, but still moved in short bursts separated by long periods of looking and thinking. In contrast, ARPA's 10-year goals for the ALV were to achieve 80 kilometers per hour on roads and to travel long distances across open terrain. With the Terragator, our first outdoor robot at CMU, we began to make fundamental changes in our approach. The NavLab, built in 1986, was our first self-contained test bed. It had room for onboard generators, onboard sensors, onboard computers, and, most importantly, onboard graduate students. The next test bed was the NavLab 2, an Army ambulance Humvee. It has many of the sensors used on earlier vehicles, plus cameras on pan tilt mounts, and 3 aligned cameras for trinocular stereo vision. The Humvee has high ground clearance for driving on rough terrain and 110 km per hour top speed for highway driving. Computer-controlled motors turn the steering wheel and control the brake and throttle. Perception and planning capabilities have evolved with the vehicles. Alvin is the current main road-following vision system. Alvin is a neural network which learns to drive by watching a human driver. Alvin has driven as far as 100 kilometers and at speeds over 110 kilometers per hour. Ranger finds paths through rugged terrain. It takes range images, projects them onto the terrain, and builds Cartesian elevation maps. Smarty and D-Star find and follow cross-country routes. D-Star plans a route using A-Star search. As the vehicle drives, Smarty finds obstacles using Ganesha's map, steers the vehicle around them, and passes the obstacles to D-Star. D-Star adds the new obstacles to its global map and replans the optimal path. Currently, NavLab technology is being applied to highway safety. In a recent trip from Washington, D.C. to San Diego, the NavLab 5 vision system steered autonomously more than 98% of the way. In a driver warning application, the vision system watches as a person drives and sounds an alarm if the driver falls asleep and the vehicle drifts off the road. The same autonomous navigation capability is a central part of the automated highway system, a project that is building completely automated cars, trucks, and buses. Automated vehicles will improve safety, decrease congestion, and improve mobility for the elderly and disabled.
Every year, about 40,000 people die in automotive accidents, and the annual repair bill is about $55 billion. Even if this technology helps to eliminate half of these accidents, the savings would pay for all basic research in information technology since the founding of ACM 50 years ago. The second area of major potential impact on society is telemedicine. Remote medical consultation is already beginning to improve the quality of care for people located in remote areas. With increased bandwidth and computational capabilities, it will become possible to perform 3D visualization, remote control of micro-robotic surgery and other sophisticated procedures. Not quite teleportation in the classical sense of Star Trek, but consider the following. If you can watch Super Bowl from the vantage point of a quarterback in the midfield, or if you can repair a robot that has fallen down on the surface of Mars, or if you can perform telesurgery 3,000 miles away, then you have the functional equivalence of teleportation, bringing the world to us and bringing us to the world. Atoms to bits. Let us look at some recent advances in 3D modeling and multi-baseline stereo theory that are essential for being able to do these functions. Can we show this short video, please?
A real-time 3D modeling system using multi-baseline stereo theory has been developed by Professor Takeo Kanade and other researchers at Carnegie Mellon University. The virtualized reality studio dome is fully covered by many cameras from all directions. The range or depth of every point in an image was computed using the same multi-baseline stereo algorithm used in the video rate stereo machine. The scene can be reconstructed with the depth and intensity information by placing a virtual or soft camera from the front, from the left, from the right, or from the top, or moving the soft camera as the user moves freely. For this baseball scene, we can create a bullseye view. A one-on-one basketball scene has also been virtualized from a number of viewpoints.
Currently, this system requires about 50 billion operations per second for the 3D reconstruction of that basketball scene you saw at 10 frames a second or whatever the video rate we were using. Instrumenting a football field with a dome consisting of 10,000 cameras will require about 1,000 times more computation, we estimate, about 50 teraflops, and will require bandwidth of over 100 gigabits into your home so that you can be teleported into the middle of the field if you so choose. Another area that will have a major impact on society will be the creation of a digital library with universal access to information and knowledge. We already have access to a broad base of information through the web, but it's less than 1% of all the information that is available in the archives. We can envision the day when all the authored works of human race will be available to anyone in the world instantaneously. Not just the books, not just the journals or newspapers on demand, but also music on demand, paintings on demand, and movies on demand. Once you have music on demand, you can throw away all of your CDs and just use the web to access anything you want. You may just have to pay 5 cents each time you listen to it, but that could be the way it works. This will, in turn, lead to a flood of information competing for the scarce resource of human attention. With the predictable advances in the summarization and abstraction techniques, we should be able to see Gone with the Wind in 1 hour or less, and a Super Bowl in less than a half hour, and not miss any of the fun, including the conclusion, in real time. Besides providing entertainment on demand, we can expect learning and education to be provided on an individualized basis. The best example of this potential, is demonstrated by the reading tutor, which provides helps to students who might otherwise run the risk of growing up illiterate. Can we show the next videotape, please?
This computer listens to you read aloud.
Literacy is more important than ever in the information age.
If the computer takes your name, help it take to you.
If the computer thinks you need help, it talks to you.
The millions of children who don't learn to read proficiently by 4th grade are at risk of growing up illiterate. The cost of illiteracy has been estimated at over $225 billion each year in industrial accidents, corporate retraining, and lost competitiveness. Carnegie Mellon University's Project Listen is working with teachers, parents, and students to develop a reading tutor that listens to children read aloud.
We hold these truths to be.
The child can use the mouse to get help with a word or sentence.
Self-evident.
We hold these truths to be self-evident that all men are.
Listening is important because children often don't know when they need help.
Bodies, dinosaurs.
Baby dinosaurs hatched from the eggs.
Baby dinosaurs hatched from the eggs.
Listening is important for motivation as well. The tutor gives the child a patient, attentive audience.
Read.
A struggling reader can let the tutor read a difficult sentence.
Recycling is helping our Earth.
Recycling is helping our Earth.
The tutor is modeled in part after expert reading teachers.
They say some mother dinosaurs
Lay eggs.
The tutor responds expressively by using recorded human voices.
I have a dream that one day this nation will rise up and live out the true meaning of its creed.
It's Martin Luther King.
What has been a real plus for us is the fact that children can use it independently, that they enjoy reading the stories, that they can prompt the story along, and that they're getting some help with individual words that they're struggling with. And they're picking up the meaning of the stories. We're real pleased about that.
I think it's fun.
So this brings us to the prospect of using time travel. Thank you. As an educational tool. In the future, it will no longer be necessary or essential for the teacher and the student to be at the same time and place. Let us see a thought experiment in which Einstein is talking to today's students. Can we look at the next videotape, please?
The equation E for energy is equal to mc squared. This equation...
Can you believe we're actually taking a class from the great Albert Einstein?
It really is incredible. But I do have one question. Who grades us for this course? I mean, sure, that's Einstein up on the screen, but who is actually going to grade the work?
Have you checked out the teaching assistants?
Teaching assistants? No, why?
Look.
Wow.
As well as...
Excuse me, Dr. Einstein. We're writing a paper about your life and would like to ask you some questions about your childhood. Could you tell us where you were born?
I was born On the 14th of March, 1879, in a small town in southern Germany called Ulm.
Well, don't you think the quantum theory is correct?
The more success the quantum theory has, the sillier it looks.
Dr. Einstein, having escaped from Hitler's Germany, how can you explain the persecution against the Jews?
The Nazis saw the Jews as a non-assimilable element that cannot be driven into uncritical acceptance and that threatened their authority because of its insistence on popular enlightenment of the masses.
Can you tell me what impressed you most about Mahatma Gandhi?
I believe that Gandhi held the most enlightened views of all the political men in our time. A man who has confronted the brutality of Europe with the dignity of the simple human being, and thus, at all times, risen superior.
Is it true you didn't wear socks?
When I was young, I found out that the big toe always ends up making a hole in a sock. So I stopped wearing socks.
So, if we had captured Einstein in living color and 3D when he was alive, it would be technically possible today to have an imaginary conversation with him. The people responsible for this at the Grand Illusion Studios, which is a spin-off from Carnegie Mellon, are hoping to create a service that will permit you to converse with your great-great-great-grandchildren in the same way. And this is not quite time travel that you've grown to expect from Star Trek, but it's another example of substituting bits for atoms to achieve an equivalent experience. With some pre-planning and appropriate data capture, future generations will be able to experience historical events firsthand and interact with the past generations. There is work underway in areas such as geriatric robotics that will help senior citizens with simple disabilities and lead normal lives well past their prime. And you can ask, can this go on forever? Transplant surgery is one way the life expectancy is being extended beyond the 100 years or so. And given the last week's news on advances in cloning, we may be getting closer towards achieving the dream of immortality. But as Nathan Myhrvold pointed out, you need to download the extra genetic experiences, the software in your brain, not just the DNA-based system. One possibility would be to imagine the example of a scenario of bringing you back to life in the 4th millennium using a frozen embryo of your clone and then infusing you with all the life experiences that you have undergone in this lifetime. The right way of thinking about immortality is not some mystical transfer of atoms from one brain to the other, I think. What I think is the right way of looking at it is from an information technologist perspective, in which you provide the clone with all the important extra genetic experiences of everything you've ever said and did, and create a rapid, simulated learning environment in which the new clone with a new brain, which can live on for another generation, gets all of your experiences, bits for atoms. Not quite immortal in the classical sense of the word, but close enough, especially given that the cloning process can go on every millennium so that you will live on to be immortal forever. except it'll be cumulative experiences of all the generations that you're learning. In conclusion, the advances of the next 50 years will undoubtedly be as dramatic as the last 50. Capabilities such as accident-avoiding cars, universal access to information and knowledge, entertainment on demand, learning on demand, reading tutors, telemedicine, and geriatric robotics will clearly come to pass. More esoteric capabilities such as teleportation, time travel, and immortality will also become possible, raising a number of social and ethical questions. We as a society have to find ways of dealing with these things. As we find ways to transform atoms to bits, that is, as we find ways to substitute information for space, time, and matter, many of the constants of our universe will assume a new meaning and will change the way we live and work. This means some of us will have superhuman capabilities, like getting a year's worth of work done in a week. Such capability can be used to further increase the gap between the haves and have-nots, or to help the poor, the sick, and the illiterate. The choice is up to us, people in this auditorium, I believe. Thank you.